questions for Edexcel IGCSE, separate sciences. So this is for paper 2, I think. So this is the contents. Magnetic field lines show the shape and direction of magnetic field. Direction is the diagram shows it a cross section through a wire. So this is the wire. When it has an X, it's going into the page. So this wire here, the current in it is going into the page. So you've got to imagine it being three-dimensional. So if the current's going into the page, if you remember, there's a right-hand grip rule or thumb rule where you put your thumb, right-hand thumb, in the direction of the current. So you'd be putting it into the page. And that means the magnetic field lines will curl in the direction of your fingers of your right hand. So the magnetic field of the wire will be the circular part of the magnetic field. And these magnetic field lines add to the uniform field that would exist without the wire between the North and the South Pole and distort the magnetic field. You can see where the magnetic field on the right of the wire is in the same direction, because remember, it's going downwards here and upwards there, the magnetic field lines. Where the two field lines are in the same direction as each other, the field lines are closer together. That means the magnetic field intensity is stronger. So the magnetic field here is stronger, and over here they cancel out a bit because the magnetic field due to this wire is upwards, whereas due to the permanent magnets it's downwards. So here you have cancellation of some of the field lines. So over here you've got strong field lines, and here you've got weak field lines, which means the wire will be pushed from the strong part of the field towards the weak part of the field, and that's what causes current carrying conductors to be deflected inside a magnetic field. Now the same force will be felt by the magnets, but because the wire is not kind of placed on a yoke, which is a metal grid, is actually connected to a C-shaped core, that the magnets are stuck in place, whereas the current carrying wire is free to move. So it's going to move this way, and that's Fleming's left-hand rule in action. Okay, so the diagram shows the cross-section through a wire, which is here. That means cross-section through a wire means as if you cut through it and the current is going in. And the way I explain it to my students is, if it's an X, it's like the back of a dart, and you'll see the back of the dart, therefore the dart is flying away from you. If it was coming towards you, you'd see the front of the dart, which will be a point. So that's how you use the symbol for a current going into the wire and a current coming out of the wire. Okay, so the wire carries the electric current into the page, as they said, and the shape of the magnetic field is shown, and it's a combination of the North Pole and South Pole having a uniform field and a circular magnetic field due to the wires. They interact with each other and produce a strong magnetic field here and a weak magnetic field on this side, and therefore the object which is freest to move, in this case the wire, will be deflected at right angles to the field lines in this direction. So they want you to add arrows, yeah? So they want you to add arrows to the magnetic field lines to show the direction of the magnetic field. Well, first of all, you've got to remember that magnetic field lines go from north to south. So all of these are going from north to south, so you've got to show that's what it is. And you'll get a mark for showing that the field lines are north to south. And then draw an arrow on the diagram to show the direction of the force on the wire, and label this F. So this will be an arrow going to the left on the page. Okay? And that's the first question. And these are exam questions which you can find on Physics and Math Tutor. So I'm just explaining them for my students. So the wire is removed and the magnetic field between the poles changes. So what if there's no wire there? You're only going to have a uniform magnetic field with parallel lines going between the North Pole, the face here, North Pole, and the South Pole. Now these are normally special magnets used, for example, to make a motor in the lab, where the poles are on the faces of these wide ceramic magnets. Okay, so North Pole's here, and the South Pole would be on the other side. So the South Pole would be above the North Pole here. They're not bar magnets where you have the North Pole at the end and the South Pole at the other end. These are ceramic magnets with the poles are wide, so that gives you the chance to produce a wider uniform field. So you should draw field lines going parallel to each other between the poles. On the edges, you could show that they start curving this way. I don't have a pen with this computer, so I'm just showing you with my mouse. Hopefully you can see what I'm trying to say. Okay, so that's a part B done, and then it says, explain how you could use a plotting compass to investigate the magnetic field around a bar magnet. Well, if you have a bar magnet, you should draw a bar magnet in the space here, and then basically you know the shape of or you should know the shape of a bar magnet's magnetic field, where the field lines go from north to south. So if you have the North Pole here, South Pole on this side, you should draw a number of north to south poles, but they want you to explain how you could use a plotting compass to investigate the magnetic field around it. All right, so there's 3 marks. So obviously you'd have to place the compass at different positions around the bar magnet and then draw which way the arrow is pointing, and the arrow is pointing towards from the north pole of a magnet to the south pole of a magnet. So you need to do it and express that so that you get 3 marks. So obviously you'd have to draw it once, keep moving it until you get enough positions around the magnet to be able to get the field lines in on both sides, and to show the various aspects of the magnetic field lines around a bar magnet. Okay, so good luck doing that. And that's a common question. So that's an 8-mark question from GCSE. And then question 2, so in the physics only paper, that means double science don't have to do some parts of the syllabus. So here it says separate only, whereas the first bit would have been something that could have gone in paper 1, is what they're saying. But this kind of question where you're talking about an electromagnet, yeah, I don't think there's any questions on electromagnets in the paper 1 exam. Okay, so those of you doing double science physics will not need to be able to do this question. So this photograph shows an electromagnetic device, so used to keep a door open. So there's a metal plate fixed to the door, yeah, and here you got an electromagnet on this part of the device. The electromagnet attracts the metal plate here to hold the door open. So that means this metal plate must be a magnetic material. Not all metals are magnetic. The electromagnet is connected to a fire alarm circuit. Okay, that's just telling us the information. When the fire alarm sounds, the door is released and it closes. So state why the metal plate is made of iron. Well, iron is a magnetic field, first of all, and that might get you the mark. And it's also a soft magnetic material. That means it's easy to induce a magnetism within it from this electromagnet. But also once it loses connection with the electromagnet, it loses its magnetism very quickly. So it's the right material to use. Okay. So that's only a 1-mark question. And then it says, describe the construction of an electromagnet. So in those of you doing IGCSE, the separate physics IGCSE exam, you need to know how to make an electromagnet. Well, an electromagnet is basically a magnetic field produced by a coil insulated wire, and you put a current through it. Excuse me, I'm just having a cup of tea while I'm explaining this to you. So if you do that, you can get one side, say it's a long coil. If you do that, you will be able to get a magnet made with electricity, which can be switched on and off. So that's what an electromagnet is. It's a temporary magnet, and it's the magnetic field due to the current in the coil. Okay, so you basically have to have a coil going around multiple number of turns in this space. You draw it, and depending on which way the current's going, one side will become like a north pole and the other side will become the south pole. And there is a way of remembering that. And if you go back to the physics and maths tutor, they've got some revision cards where you can go through each part of the topic and make sure you've understood it. So this will help you put your words in the right place. And also you can find the answers to these questions on the website as well. Okay, so it's a very good website for revision. And then it says, describe the changes that allow the electromagnet to release the door when the fire alarm sounds. So an electromagnet, as I told you, yeah, the construction of it requires a switch as well, so you can switch on. So you need a power supply, like a DC power supply, like a battery, and a switch, yeah, in your construction of the electromagnet. And once you have a DC power supply, like a battery or a cell, and you've got a switch, you can switch on the current and switch it off. And when you switch it off, it will release the piece of iron, the metal plate, because the electromagnet is now no longer magnetic. Okay, it's switched off. So this is what they use in junkyards to lift up steel cars. Okay, so describe the changes that allow the electromagnet to release the door. So you would say the changes are when you switch off the current, yeah, the electromagnet will release the door, or because it is no longer magnetic. It's only on when the current is on, and that should get you the mark. So when the fire alarm sounds, it must have a way of switching off the current in the circuit. So there may be a way of controlling it with the fire alarm, that it actually switches off the switch in the door, the electromagnet switch. Okay, so that's 2 questions done, and then I'll come back and do more questions like this if you find it useful. So I'll speak to my students next week when I go back to work and see if they like this style of video. Thanks very much for watching. See you in the next video. Like, share, and subscribe if you want to be notified of when the next video is. Thank you.